G'day guys. What I'm going to be going through today is an introduction to our calculus unit for NCEA Level 3 Calc, specifically focusing on functions and limits. So we've kind of hit the wall in terms of conics for distance learning. We really need to be back in a class to focus on the higher level thinking around that, but we'll see how we go. So what I'm going to be introducing today is functions. So what is a function, basically? So you could you might want to actually go online and look up what a function is and get some other points of views, because I'm kind of winging this lesson. I haven't taught calc by a distance before, but I feel like this is the most logical place to start. So a function is a lot of people talk about mappings. So a function would kind of map x values to the Cartesian plane, the xy plane. So I've drawn this pretty poorly, but basically if this is the x-axis, then a function would take one of these points and map it into the Cartesian plane, like so. So I might take all those points and then you'll get a map. So this might be the function y equals x squared plus 2, right? If that's been moved up too. So it's taking all these points here and it's giving us some output. And up until year 12, mostly your function's been defined as an input of x and an output of y. So I'm just going to introduce a new bit of notation. So I think of a function as a machine. So let's take f, and it's a machine. If I give it something, if I give this machine something, say x, then I get some sort of output f of x. And so you can think of the machine as a calculator. So if we have this calculator, then you can see actually we have a function of squaring. So if I give it anything, if I give it some number, I give it 5, it will spit out 25. And that's kind of what's happening here, right? If I give it 9, it outputs 81. So it's a machine. So another way of writing this function is, instead of having a y and x axis, we have an output axis, f of x, and our input axes. Okay, so what we kind of call these is the domain, right? That's where we are, and the range, where we want to be. But we don't get into domain and range too much in level 3 NCEA. So that's kind of the gist of a function. So it's a relationship between sets of numbers, and usually in our level each number has an output, and each output corresponds to just a single number. It's usually the gist for us. So that's the basic of it. What I also want to look at is if we have some sort of function, I don't know, something like this, looks like it's an exponential. We want to look at what happens as we get really close to certain numbers. So if I was to come down this line and come towards this number, and I was to go up this line and get towards this number, what actually happens as we get closer and closer to it? And that is what we're going to be going through next for our limit theory. So so a limit, its definition basically is, tells us how a function behaves near a point. So basically a limit tells us what happens near a point. So just grab a bit of scrap paper. So an interesting example would be f of x, sorry, some function, some output, right? So we've got some output. What would happen if we inputted 2? Well, if we input 2, we'd get 2 squared minus 4, and that's 0, and x, and 2 minus 2 is 0. So the way we would do this is f of 2, right? F of our input, what is our output? So I might just do a wee aside. If I had a function, say f of x equals 3x plus 1, then I could say f of 1 and then tell you what that is. So f of 1 would be 4, f of 3 would be 10, and so on. You could just, that's how we write that notation. So if we put 2 in, we get 0 over 0. And most of you will know that if you divide by 0, it means our function is undefined. So what does that mean? What does that look like to us? And what we can do is we can actually have a look at what is happening as we get closer and closer to 2 from both sides. So let's go at 1. So let's go when we're at 1. When x is 1, what happens? Well, we get 1 squared minus 4. So 1 squared minus 4 on top, negative 3, divided by 1 minus 2. So we go to 3. So we're up here somewhere at 3. And let's have a look if we're 1 away from 2 on the other side. So let's have a look at what happens when we're at 3. We'll get 3 squared minus 4, 5, divided by 3 minus 2, 5. So when we're at 3, we're at 5 up here. But we want to know what's happening at 2. So what we do is we look closer and closer to 2 to analyze what's happening. So I could go to 1.5. So 1.5 squared minus 4. That's the top. I'm just inputting 1.5 into my function and divide by 1.5 minus 2 on the bottom, 3.5. So it looks like we're getting closer and closer to 4. Okay, and if I went to 2.5, what's happening? So I'm doing this quite quickly now. 2 squared minus 4, and I'm dividing that by, 2.5 squared minus 4 minus 2.5 minus 2, and we're getting 4.5. So it looks like we're going to be getting close to 4, but it's undefined. So how do we express that? Well, this is actually a linear function looking like this. So something like that. So this function is defined for all numbers except 2. 2 is the only number that would make this undefined. So if it's undefined at 2, what we do is we put an open circle. All right, so it's like there's a jump. It's like you get to 2, and that's infinitely small, but we still do a circle. And then we would have to jump over that if we could. It's undefined. If you were to actually do this, we think of we'd have to take our pen off the paper to do that function. So what we say is that it's non-continuous. Non-continuous. It is undefined. And so the notation for this is the limit as x goes to 2 of f of x equals, or you could actually put the entire function in, the limit as x goes to 2, so under the lim we have x arrow 2, x squared minus 4 over x minus 2. Well, if we kept going closer and closer, you'd notice that we would go to 4. So the limit as x goes to 2 from the top and the bottom is 4. Now the function isn't 4 at 2, it's the limit. So as we get closer to 2 from the left and right, what number are we getting closer to? And it's 4. So that would be kind of your answer. If you're asked for what is the limit as x goes to 2 of this function, it is 4. Okay, so we're going to look at an example here. So example here. So intuitively you would say that the limit of this function as x goes to 1 is 0, right? As we get closer to 1 from this side and side, we get closer to 0, we get closer to the x-axis. Just strain that up in the camera for you. So, how do we define this function? Because undefined, well, it is defined at this point. So what we do is we go f of x is equal to, now it's got 3 parts. So we do these big curly brackets, look better in a textbook than what I'm doing. But this first part, that is x minus 1. That's the line x minus 1 is a gradient of 1, and it's been shifted down 1. Now this other part, alright, my camera that's balancing on a 1 meter ruler poked through a cardboard box just fell down, so I'll continue where I left off. Well, we just defined that function as x minus 1, and this function is going to be x, negative x plus 1, isn't it? So where is this defined? Well, it's defined when x is strictly less than 1. When x is less than 1 but not equal to, it is that function. When x is strictly greater than 1, when x is greater than 1 but not equal to, it is this function. And so what is it when x equals 1? Well, when x equals 1, this function is 2. And this is how we're going to start defining what is a piecewise function. So piecewise function, because it's made of pieces. Okay, so what is the limit as x goes to 1 of this function f of x? Now remember, I haven't said it, but notice how in the last one I went from the left and the right, and if I get to the same, if it looks like I'm getting the same number, then that must be the limit. So the limit is 0 even though f of 1 is 2. The value when x is 1 is 2, but the limit is 0. That's where you would be getting to. If you're a really small person on that line, you would think you were going to end up at 0, but the function has actually got that removed, and it's been moved up there. Okay, here's another example, or what we're going to call this is case 1. What is the limit as I go from this side? So the limit as x goes to 2 of this function, which is made of a parabola, x squared, and some line negative x plus 7. So if we were to define this function, one function is x squared and the other is negative x plus 7. Now it's x squared when x is strictly less than 2, and it's negative x plus 7 when x is greater than 2. Notice how there is no definition of this function when x is 2. If it was defined, we would have a filled in dot. So I'd fill that in if it was defined there. Or if it was defined there, I'd fill it in. So the limit, well, what happens when we get closer to 2 from this side? We get closer to 4. And when we get closer to 2 from this side, we get closer to 5. And because those are two different values, the limit does not exist. There is no way to know where you're going to two different values from the left and the right. So this case is no limit. So you can have no limit. So what we've seen so far is you can have a limit. You can approach a certain point, but at that point be defined elsewhere. Or you can have no limit, because when you get to a value from either side, it's different. And we're assuming for all of these cases that these go on to infinity and negative infinity. We're assuming these functions go on forever, so it's implied there that's less than infinity. Okay, what about case number 2? All right, so we've got a function, f of x or y is equal to square root of x. So you can't square root in the Cartesian plane, in the real numbers, you can't square root a negative. And so what we're going to be looking at is f of x equals the square root of x, no limit as x approaches 0. And here's an example of having a solid point. This function is defined at 0 because you can square root 0. So it is defined at that point. So we don't do a hollow circle, we can fill it in. So basically so far is that if a line jumps, so a jump, or there is a gap, or if there is some sort of end, such as these, okay, this loosely speaking, there is none of these functions would have limits, okay? And our third case is this case here. So it's a hyperbola. And notice that what was the limit as x goes to 3? Well, as x goes to 3 from the right, we go to positive infinity. And as we go to 3 from the left, we go to negative infinity. So the limit as x goes to 3 of this function is undefined as well. No limit exists. So, and this is that would be a number, because that would be 5 over 0. So again, it would be undefined at that point. But say it was a curve, you didn't know what it looked like, but you could see the bottom was going to 0, you would have to look at a number close to that number from the right and a number close to it from the left. So if I was to put in 2.99 into this function, what would that look like? 2 would go 2.99 plus 2 divided by 2.99 minus 3. And that's negative 499. And if we look at it from the right, then we could go let's go close to it from the right, 3.01 plus 2 divided by 3.01 minus 3, and we get 501. So we've got a really big number, a really big negative number, or really, really, really small number, by the way, and a really, really big number. So two different limits on either side. So hopefully that limit stuff makes sense. I'm going to be posting some questions on that. Any queries, just hit me up. Sweet.